In 1992, a new sports car appears. The McLaren F1 is the fastest, lightest, and most technically advanced production car to date. For many observers, the F1 confirms designer and engineer Gordon Murray as an outstanding automotive talent.
What I love, generally in design and car terms is simplicity and elegance. And that is absolutely the way that Gordon thinks.
The thing that makes the great designers is the ability to take fresh looks all the time, to approach from a different angle. Almost to sit down with a clean sheet of paper and not necessarily drawing four wheels.
Murray has spent 2 decades in the world of Formula One, continually searching for a competitive edge.
Gordon really was the guy that did things on his own. Come up with the ideas, design the car, followed it through, see how it was manufactured. It was him and Colin Chapman, really.
His radical designs lead to one race-winning car after another. But those years of F1 experience are now focused on new and different goals.
If someone can make a car go 241 miles an hour, they can probably make a car go 100 miles per gallon.
For Murray, 100 miles per gallon is just one of many challenges in his new chosen arena, the complex business of mass-produced road cars. This is the inside story of a lifetime of innovation and a remarkable and ongoing design journey.
I was sitting in the traffic once, stopped. I looked around me and I thought, 80% of the cars around me are huge and 80% of them have one person in them. And that cannot be sustainable.
Gordon Murray's career as a designer has been driven by a passion for motoring itself. But that passion seems increasingly under threat.
We're motor people. We've always been motor people. We're surrounded by these arteries which are our life, You can't take away the road network. You can't suddenly say, stop driving your car. There'll be a revolt.
So in recent years, Murray's focus has turned from racing to the road.
It was nothing to do with environment. It was nothing to do with the quality of air. Greenhouse gases didn't come into my mind. It was purely, this is not sustainable and this is not fun anymore. So what can we do? What would solve that? The only way is to encourage people to go smaller and lighter.
Smaller and lighter is one of Murray's fundamental design principles, repeatedly tested in Formula One competition. It's 1973, and Murray's career as an F1 designer is about to start at Brabham. The team has been struggling, but it's under new management, and incoming boss Bernie Ecclestone is taking a risk. He has promoted an inexperienced young South African to the job of chief designer.
Well, I didn't know Gordon at the time, obviously. He was just another guy in the drawing office. So that's as much as I know about Gordon.
I was incredibly young and very naive. Straight off the banana boat. And only having produced my own engine and my own car at very low club racing level in South Africa. So it was a great opportunity. And if I'd stopped and thought about it, I probably would have had a panic attack.
I think the feeling in the motor racing world was that that was an awful lot being dropped onto one young man's lap. And is he going to buckle under the load, or is he going to pick it up and carry it?
Murray's first challenge is to improve on Brabham's abysmal performance. For his first car, the BT42, he rejects the conventional layout of the time, rectangular bodywork with a triangular engine, and makes a radical attempt to lower the centre of gravity for faster cornering.
Every single DFE engine Formula One car had a kind of rectangular tub with a triangular DFE bolted onto it. And Gordon looked at it laterally as he looked at most things. He thought, well, if you've got a triangular-shaped engine, why not have a triangular-shaped tub?
I did a triangular cross-section like this. With the fuel, the fuel was kept much broader and lower in the car, so the centre of gravity of the fuel was much lower.
In a time before wind tunnels and computers, Murray's new package also gives a significant aerodynamic advantage.
The BT42 was like an upturned saucer. That's why it was so a radical shape. So very little air went underneath the car, and most of it went over the top, because all the air that goes under the car produces lift, which counteracts the downforce you're getting from the wings on the car. So it was radical in layout, but it was also radical in aerodynamics.
It emerged as absolutely the tiniest and one of the best thought out and one of the best integrated designs that we'd seen in Formula One.
I think he put himself on the map at that Spanish Grand Prix in 1973, because the 42 came out the box and did the business. And that's how good he was.
Well, I think with all these things, you've got to put a bit of luck into it. I mean, I just thought he was the right guy, and I got lucky. He was.
At his facility outside London, Murray's team of designers and engineers, many of them with F1 experience, are working on a self-imposed challenge: to design and build an inexpensive, lightweight city car. It's codenamed T25, being Murray's 25th car program.
With T25, I didn't start with an idea at all. I started with a problem. Today, with all the promises of hydrogen and hybrids and electric cars, if you could take 10% off the weight of every car, the effect in the next 10 years, just 10%, the effect in the next 10 years would be more than all the hybrids and all the electric cars on the planet.
The first step is to evaluate other small cars.
When you're trying to achieve something in a design arena that hasn't been achieved before, you need to start off with a benchmark. You need to know what it is you're trying to improve on.
Two small city cars have been chosen: the Mitsubishi iCar and the Smart. They are dismantled part by part, with each component being weighed and evaluated.
The process of benchmarking for cost and weight is microscopic. You go through every single component, subcomponent and assembly on the car and set yourself targets for reducing weight and reducing cost.
Those parts that can be used are reassembled, system by system, within the dimensions of the T25 package. But there are many gaps to fill.
A lot of the elements of T25 we've had to do ourselves because we just couldn't find anything small enough or light enough. So we've actually had to engineer a lot of the components from scratch. We even had to make our own wheels because we couldn't find wheels light enough or small enough.
Unlike most car manufacturers, Murray's team is still using old-fashioned full-scale schematic drawings.
The advantage for us is we can talk about the overall package of the vehicle rather than working on a small screen in a local environment per designer.
The lower edge of the plinth is about here, isn't it?
being able to scribble on the full-size layout moves the design process forward much quicker than you could on CAD.
Good afternoon, gents.
How are you doing? All right? Just doing the sort of drive shaft plunge and depth measurements, and making sure we've got enough angle in the drive shafts and checking.
The drawings are used to construct a so-called lab car.
You know, normally when you build a lab car, the reason you do that is to sort out all the application work on the electronics and the electrics and test the systems on the car, like the fuel system or the water system, cooling system. And generally, you have a long, long list of problems that you have to work through and fix. I would say that building a car to sell for £6,000 and designing that for high volume production where you have all the quality control issues under control is 100 times more difficult than designing a McLaren F1 or even a racing car. It's certainly the biggest challenge I've ever had from a design point of view.
The tendency is all too often to think of Formula One as just the business of the gladiators driving the cars. Actually, so much of Formula One history is about the designers designing things that give an advantage to the guy driving that car.
Innovation is essential to a driver. You want an unfair advantage all the time. You know that, for example, in Formula One, you know that the designers read the regulations once to see what they say, and then they read them again to see how they can get around them or take an advantage. And that's the brilliance of it, that's the excitement, that's what drives it forward, that's why it's so high-tech.
There are periods of motorsport where you can see it really, really clearly. That clever interpretation of a rule gives an extraordinary advantage.
In 1978, Murray's search for a competitive edge is taken to new extremes with his extraordinary fan car.
The fan car was born out of necessity, really, because Lotus had invented ground effect.
Colin Chapman's Lotus team have worked on their aerodynamics to achieve so-called ground effects, sucking the car to the track and thus allowing more grip and higher cornering speeds. Lotus's success is a challenge to all the teams. Murray urgently needs inspiration, and he finds it in the rulebook with a loophole in the wording. The regulations state that a movable device, primarily used to give an aerodynamic advantage, is not allowed. Murray therefore designs a large fan which, he can argue, is primarily to cool the engine, but with the crucial side effect of sucking the car to the road.
And I did the sums, and I had to do them several times because I couldn't believe the downforce multiplied by the number of square inches under the car. You know, it was just an astronomical figure. I stuck a bloody great big fan on the back of the car, driven off the gearbox, and sealed the entire motor car to the ground. So you had this whole area under suction. The difficult bit, in 3 months we had to redesign the whole car and come up with a fan that would survive nearly 8,000 revs. That was 18 inches diameter without falling to pieces. And all the early ones exploded.
The Swedish Grand Prix at Anderstorp, and Murray's secret weapon is unveiled for the first time.
I think for the majority of the teams it was a novelty. When they first saw it on the Thursday, word went around that obviously we had this car and it had a fan on the back of it. I remember Colin Chapman immediately saying it was illegal. And every time the car came in fact even when we raced, we had a dustbin lid that we used to actually put over the fan.
The fan car could get as much downforce standing still as it could going at 180 miles an hour, which meant you could get a 2G standing start and you could go around hairpin bends just as quick as you could around 150 mile an hour bends, so it had a massive advantage.
Well, nobody took a lot of notice of it until it started. I think people thought it was going to be quick, and they were right, but we tried to make sure that it didn't look quick.
Bernie made the drivers qualify on full tanks because he didn't want to be too fast.
The other teams, led by Colin Chapman and Lotus, are outraged by Brabham's huge advantage, which they consider to be illegal.
There's one thing that stuck in my mind about that car was all of the other drivers who had to follow it, complaining that they were just had a face full of dust and rubbish and anything else that this thing swept up off the racetrack.
Mario would come in and say, "Hell, man, that car, it's chucking rocks. It's like, you know, I have to duck, it's going to kill."
I know we were getting blasted tremendously. The obvious thing is, if something you think is working better, you try to use whatever excuse, you know, to say it's not good.
Niki Lauda wins the race by 34 seconds, but the fan car is doomed.
The other constructors, particularly Lotus and Tyrrell, lent on Bernie heavily to withdraw the car.
We were inside the regulations, for sure. But Colin said, if we don't mind, everyone will be doing this. And it's a little bit crazy, because there's maybe no limit in the end.
Bernie came to see me and said, "Look, this is my position. We can run the car till the end of the year. We'll almost certainly win the championship. But I think the Constructors Association is more important." So I was very, very pissed off, I have to say. But I did withdraw the car.
"30 years on, Murray's new city car concept faces one fundamental problem.
I discovered why people didn't make what they call sub-A segment cars, small city cars. And that's because you don't make any money on them.
There was an issue about how we break.
Because the tooling and the development costs for a small car is almost the same as a bigger car. So people would rather build larger cars with more content and make more profit. That's when I started thinking, well, if this is going to really work, there needs to be a new way of making the cars that is cost-effective.
This is how cars are made, more than 50 million of them every year. Mile-long factories filled with thousands of huge presses, punching out 400 steel panels per car. The factories are often located to take advantage of cheap labour.
When you think that the cheapest places in the world to manufacture these large components are obviously China, Asia and South America, and the biggest importers of these products in the automotive industry are North America and Northern Europe, it kind of paints a picture of the environmental damage that is being done just through transportation.
Murray's team has decided that the big manufacturers' processes, with all their associated environmental costs, cannot be used for the new car. They have found a simple alternative. Steel tubing is lightweight and available all over the world.
It's not only widely available, but it's also very cheap to produce. Tube mills are relatively cheap to set up. They don't take a lot of floor area. They don't need a lot of equipment.
For many years, tubes were used in racing cars to make expensive and complex space-frame chassis. But today, laser cutting techniques enable mass production at this type of chassis for the first time. The team is using this concept for T25, but the tubular chassis isn't strong enough on its own. So they have adopted another innovation from the world of motorsport.
We've developed a very low-cost, low-energy composite panel like a Formula One monocoque. And that gets bonded into the frame permanently, and that then makes the frame very stiff in torsion and bending and manages all the crash loads.
It's one of these situations where the sum of the parts is better than the individual components themselves.
At this early stage, it's a basic combination of tubes and panels. But, in Murray's view, the simple design of the chassis offers a significant competitive edge when it comes to cheaper and greener ways of mass production.
Wasn't the idea that that would be frangible, so when you had a big high-speed accident, that would fail and drop?
In the early 1980s, Formula One sees an ongoing battle between Murray and his design rivals as they search for aerodynamic downforce and faster cornering speeds.
The downforce was getting quite ridiculous. You know, we were producing nearly 5G laterally, and the drivers were getting pretty close to sort of needing G suits in those days.
The sports governing body, the FIA, announces a new rule. To lessen the downforce and reduce speed, all cars must have a 6-centimetre gap between the bodywork and the road.
The British teams, led most ingeniously by Gordon, decided that, well, at what point is this 6-centimetre gap going to be checked? It can only be checked by a scrutineer when the car is stationary, because not that many scrutineers are fit enough to run at 180 miles per hour beside a Formula One car with a measuring tape.
Driver-operated mechanisms are also banned, so Murray needs to find a way of keeping the car close to the ground when it's at speed.
We came up with a system where we put a hydro pneumatic cylinder in the rod, where half of it was air and the other half was hydraulic fluid. And then from the air side, that ran off to a really small, a tiny little micro valve and a filter to stop the micro valve getting blocked.
When the car is lapping at speed, the wings push it down, well below 6 centimetres, and the slow-release micro valve prevents it from rising up again.
And then on the slowing down lap, the driver did a slow lap, and all the fluid pushed back past the valve, and it came back to 6 centimetres.
The other teams are convinced that the system is illegal and try to find out how it works. But Murray comes up with a distraction to throw them off the scent.
Inside of the car, when you took the bodywork off, we made a big empty aluminium box with a few wires coming out of it. Of course, whenever the car came into the pits, everybody looked at the aluminium box, and nobody looked at the hydraulics. So for the first 3 or 4 races, nobody knew what we were doing, and we just continued to nail everybody, which really miffed the rest of the teams.
The regs are saying that the car should be 6 centimeters high in any circumstance.
No, they don't. No, they don't. The regulations say all measurements shall be taken with the car stationary on a flat metal surface with the driver on board and the engine running.
So in your opinion, there is no doubt that everybody will have the same system in a few races?
You can do the same thing with normal springs. Williams do it at the moment with bump rubbers and normal springs, and they run a little bit higher than us. And they go a little bit slower. They're bad losers, basically.
Every team tried to get it to work, but we'd had the benefit of doing it all winter, and nobody could get it to work. They all sussed out what it was and spent 3 or 4 races trying to get it to work. And eventually the FIA gave up and said you could just have a lever that operated the car, because they realised every single car went below 6 centimetres anyway when it got on the circuit, so that it was an unenforceable rule, really.
Murray's innovative designs for Brabham take Nelson Piquet to 2 Formula One World Championships.
He was very, very good. He sort of motivated the drivers, and they all respected him and realized he was the number one. And they were lucky to be driving a car that he designed.
The T25 program has reached a technical milestone. It's a long-awaited moment as the lab car is ready for its first ever test drive, alongside the Mitsubishi and Smart benchmarks. The car is powered by a tiny petrol engine, perhaps a surprising choice given the widespread debate about hybrids, electric cars and hydrogen fuel cells.
Well, to start with T25 for the first prototype, we decided to use petrol. I was quite interested to see how good petrol could be in a very lightweight, efficient vehicle. Just how low you could get the CO2 emissions and how good you could get the fuel consumption.
This is a petrol-driven vehicle which seems to be at the moment out of fashion with all this interest in electricity. It was hydrogen. That's now been replaced in the public mind by the future being electricity. And now we've got somebody coming along with a very fuel-efficient engine and a car that is designed to work around that.
I think it's extremely important that we remain agnostic about what form of propulsion we use in our cars in the future, and that we try to design cars that will accept any form of propulsion, you know, be that a petrol engine or a fuel cell or electric drive, because the type of propulsion that we choose for our cars is going to vary. There just won't be one solution, and it'll vary according to how you drive your car, where you drive your car, and how far you drive your car.
Murray and his team have all but discarded the emissions discussion to focus on what they see as the elephant in the room: the manufacturing process.
Most car companies will tell you that the manufacturing process is insignificant compared with the running tailpipe emissions of a car, but actually when you do all the true numbers, it is very significant.
I think if you're going to radically alter a car's environmental footprint, you've got to absolutely start from scratch. You know, you've got to look not just at the way the car is designed, but also at the way that it's built. You've got to look at the kind of factories in which it's built. You've got to look at the ways in which the parts are shipped to those factories, and that requires a completely fresh approach.
A fresh approach to a process that has remained essentially unchanged for 100 years.
It's a complete rethink on how we make motor cars, and it's really the first step change since the Model T Ford, when Henry Ford first stamped steel panels and welded them together.
Station 18. Install drive shafts assembly to transmission.
We're actually starting from scratch with a new equation, which is an open heart, look at a complete carbon footprint of a car from literally cradle to grave.
Murray's idea is that cars can and should be manufactured in a new way. The concept is called iStream, and it aims to take Formula One technology, such as composite materials, and transfer it into vehicles for the everyday motorist. By simplifying every stage of the manufacturing process, the iStream factory is much smaller than a standard car plant. The end result is a low-energy factory producing lightweight, low-cost cars.
Our iStream technology is completely disruptive relative to normal stamped steel cars. It doesn't use any major stamp component in the car. It doesn't need a stamping plant in the factory, it doesn't need a spot welding plant, doesn't need an e-coating plant, and it doesn't need a paint plant.
We're talking about an 80% reduction in size and investment of the plant and the factory. It's just a complete rethink. It bears no resemblance to the way cars are made at the moment whatsoever.
In short, Murray's vision is for a new way to mass-produce cars, and an end to what he regards as the wasteful, outdated processes used by automotive manufacturers across the world. Until recently, mid-race refueling has been a distinguishing feature of modern Formula One. But in the early 1980s, things are different. The rules specify a maximum fuel tank size, but no minimum. Murray senses an opportunity and redesigns the Brabham.
And we just turned up at the first race with a car with only half fuel tank size, which meant, of course, the design of the car could be much more flexible because the tank size was only half the length of a conventional tank. We were putting new tyres on halfway through the race, fueling halfway through the race. Just ran away with the races, basically.
During his 16 years at Brabham, Murray is one of the first to experiment with carbon fibre components. He is credited as the inventor of the now standard carbon brakes for F1 cars. By the late 80s, his talent for finding new ways of doing things is in demand, and he is repeatedly approached by other teams wanting to lure him away from Brabham. This is always done in secret.
Nobody dared talk to you if you worked for Bernie because they were frightened of what was going to happen to them, I think. So you were pretty unapproachable.
The McLaren team has made several offers, and at the end of the 1986 season, Murray accepts.
I think when Gordon was invited to join the McLaren team, there were two motives for Ron to do that. One was to acquire the services of probably the most innovative and by that time celebrity designer within the racing car world, and also, perhaps even more so, to deny his services to McLaren's rivals.
I think everybody was looking for something new after, John left. And of course, Gordon came with a big reputation. I think we're looking forward for Gordon to bring new ideas. He's always been very original in his thinking of developing things.
According to Murray, his first car for McLaren is a direct evolution from his final design layout for Brabham, the radical but unworkable BT55.
When I left Brabham at the end of that year and went to McLaren, all I did was I just took exactly this layout and reinstated it in the MP44. We got something like a 7% reduction in frontal area and an 11% aerodynamic improvement. And these days, if a Formula One team gets a 0.02 aerodynamic improvement, they have public holiday.
The resulting car sets the scene for an epic battle.
In Prost and Senna, we had two really good engineering drivers. Both of them understood what made cars handle and what made them go quick, and both of them worked very well with the engineering staff. Alain Prost in particular had this reputation before I started working with him as being like, the really good guy. And Senna was very clever too, particularly on strategic stuff.
I remember Senna would move his wings by millimeters and could feel the difference. So, it's very important to have that kind of caliber drivers to interact with somebody like Gordon.
The rivalry was probably at its peak with Prost and Senna because it was such a competitive car and such a competitive season in '88. What you did find was happening is you'd get double bluffs and then you'd get treble bluffs. So you know, you'd have one driver saying, well, yeah, I think I'll run the D tyres, very quickly in the discussion. And you could see the other driver thinking, well, I know that means C. He's never going to run the Ds. And then the first driver would end up by choosing the A's at the last minute. You know, there was a lot of double bluffing going on.
McLaren goes on to win 15 out of 16 races in the 1988 season.
McLaren had it in the bag. They should have won every Grand Prix. They clearly had the dominant package, and nobody could develop fast enough to challenge that within a season.
After the first races, if it wasn't, it was Ayrton winning, if it is, you know, after you win 2, 3, 4, 5 races, you know that you have the best car. We definitely had the best drivers, but of course to be dominant in this way, it's never happened before.
If Murray's new road car is to appeal to the car-buying public, it will need to look the part.
People still are very emotive about buying cars. It's a big purchase. It's something where style always plays a big part. I think no matter how good the car is from the point of view of efficiency, performance, how low cost it is and how low cost it is to run, if the car isn't funky and desirable, you're not going to sell them.
I'm trying to make the car look modern but very classical so that it's not going to age quickly. Styling a small car is a lot harder than doing a 200-mile-an-hour sports car. There's not a lot of real estate for the styling guys to express themselves on, and everything is really constrained. It's quite difficult to come out with anything that doesn't look like a box.
This is a seating buck, an old-fashioned but useful way of packaging the vehicle's ergonomics away from the computer screen.
It's subtle things like the belt line, the height of the window that runs past you. You can move that up and down 20 millimeters, and you can go from feeling claustrophobic if it's too high to unsafe if it's too low. And that sort of stuff you can never see on a screen.
Apart from its diminutive size, the T25's most distinctive feature is its central driving position.
So this is the central seat, and 3 people in something a foot shorter than a Smart and about a foot narrower than a Smart. It started, actually the concept started as essentially a single-seater, like a 1+2. But actually, as we got into building, this is called a seating buck, as we got into the ergonomic study, we soon realized that you could actually get 3 full-grown people in the car with a few design changes.
The canopy door is another key design feature.
Getting into the centre of the car is much improved with this unique door system where a canopy structure moves up and out of the way, permitting easy access to the central driving position for an adult with 2 adult passengers.
Back in the early 90s, Murray is kept busy by day at McLaren, But at night, he's moonlighting to produce a new road car.
Gordon always been a fan of Colin Chapman's Lotus 7, and I think it was his chance to do what he thought the step moved on, and this was his one of doing it, yeah.
And Chris had said for ages, you know, he'd like to make a car and he'd like me to design one. And I said, well, if we do one, it's got to be something that breaks new ground again and lightweight. Why don't we try and do a car that's, you know, the lightest production car the world's ever seen? And that's how the rocket was born.
At the time, the world's lightest road car is the Lotus 7, designed by Colin Chapman and weighing just 1,100 pounds. Murray and Kraft set out to cut weight in every area of the new car. They're even tempted to use a light but powerful Yamaha motorcycle engine, giving 140 horsepower per litre.
You know, with a motorbike engine, we can get down to 350 kilos. But motorbike engines rev too high for conventional gearboxes. They're rev far too high to be comfortable as a road car at 11.5, 12,000 revs.
The solution is a bespoke Wiseman gearbox, giving 12 forward gears and 6 in reverse.
Here's a chance to have a road car with essentially a 12-speed transmission, because he uses the Weissman gearbox on top of the Yamaha gearbox. So you have a 13,500 RPM red line. So you're really driving a Formula One car on the street that gets 40 miles per gallon, weighs 775 pounds. It's a bit disconcerting to get into the car and realize I'm now half the weight of the vehicle. It makes you feel somewhat...
We had that romance. Those cars have a romance about them as such, and even today on the roads, if you take them out now, people smile at you. They just love the look of it and they smile at you. Yeah.
If ever I need to be reminded, or I need to remind somebody else what lightweight can do for vehicle dynamics, you know, I drive the car myself. I'll say to somebody, get in that and drive that and see what that feels like. And it's still the lightest car in the world by about 100 kilos, I think.
At a secret test track in Sussex, the T25's design journey is coming to an end. It's taken 18 months from concept to first test drive.
I mean, it's always a very special moment for any car that we've designed or I've designed to sit in it and drive it for the first time. Well, when you see the car running with another car, in this case the Smart, it's a real-life comparison. I mean, you can stare at numbers as much as you like. I mean, we know the thing is 200 mil narrower across the body, 300 mil shorter. What struck me as they were going away was there's the Smart, which holds 2 full-grown people, and T25, which holds 3, and it just looks tiny compared to the Smart. So it was quite a shock, actually. Today's really shown that the car is what we want it to be. You know, it feels safe, it feels solid, and it feels good fun to drive. When you're that close to a program, as these guys have been, it's quite difficult sometimes to sort of step back and get the perspective that you need to judge the car properly. But I think when you see it run and you have somebody drive it and report back that it feels good, then it's a very positive thing.
I think to purchase a McLaren F1 new was a statement of religious belief as much as it was a decision to buy a motor car. It was because what you were buying into was the religion of Gordon Murray, of his thinking, of the quality of his thinking, of the originality of his thinking.
And you have to remember, when it came out, it was on the heels of a lot of pretenders. And, of course, this was the real deal.
Nothing has been built, before or since, that can even begin to compare with that car. It is the ultimate piece of high-speed kit ever saw tarmac, road or race.
In 1988, the idea of building a road car is first discussed at McLaren.
McLaren were at that stage by some way the most successful Formula One team, and they had nothing to sell to the public, nothing to parade their capabilities.
We decided that McLaren contribute more than just Formula One, that we could take this technology and translate it to a road car.
And that's something that I'd harbored, you know, inside me for a long time, to try and out-Ferrari, if you like, try and do the ultimate sports car.
To build a supercar adequately, you needed a jolly good idea of what was available already. And what is that indefinable thing that makes a car super?
By the late 80s, there was a motley collection of supercars available, from Ferrari's Savage F40 to the urbane Honda NSX.
I had driven a lot of supercars and big sports cars, and I hated certain elements about them. Just a long string of pet hates, much more than sort of pet loves, if you like. And I was determined to exorcise everything I hated about sports cars.
You know, the fantastic thing that Gordon had with the F1 really was that he had a genuinely clean sheet of paper, which anyone designing a modern Ferrari, for example, does not have. Because if you're designing a Ferrari, you have to end up with something that looks and sounds what people think a Ferrari should look and sound like.
These sketches were made by Murray when he was 22, an early iteration of the F1's radical arrow-shaped seating position, the driver flanked by two setback passengers.
The McLaren F1 was never going to be a car full of compromises. There was always a lot of encouragement from Gordon to think outside of the box in the way that we solved problems, and he was very encouraging with designers to be a little bit braver in some of their solutions.
Normally you'd have hundreds of designers working on a program like that, and we had 7, and I think that's why it was so special. It was very hard work to do it in a time, obviously, but very satisfying and a hell of a lot of fun.
The F1's engine is a specially designed V12 unit from BMW's motorsport division.
I wanted the engine to have great 1960s sports car character with noise and high revving and stuff. Worked with that genius Paul Rocher in BMW and built an engine with no flywheel and a carbon fibre clutch. So the thing revs like a 600cc motorbike, you know, which no other supercar does.
The F1 instantly becomes the world's fastest production car. 241 miles per hour, 627 horsepower, and weighing about the same as a Ford Fiesta.
I suppose what got my notice, inevitably, was the prospective stratospheric performance envelope of the car, was it looked as though it was going to be a quick one. I mean, that's what got your attention, but that's not in itself a good reason for buying a car. In fact, you know, normally or certainly the price or the prospective price that was being advertised was, you know, was as good a reason as any not to buy the car.
I remember thinking, there's a car coming out that's going to cost $1 million. Well, that's ridiculous. What a stupid idea. This was in the 90s. So obviously it was $1 million was even more money than it is now.
But the price is forgotten once the F1 is on the road.
Remember the first time he ever took me for a ride in it? I sat next door to him. He's in the middle, of course. I'm sitting there. He said, "Now, are you holding tight?" I said, yeah, come on, get on with it, get on with it. He said, "Listen, just brace yourself." I said, yeah, come on, get on with it. The thing was unbelievable.
The car is so much better than you are. It's like I say, it's a bit like having sex with an aerobics instructor. You know, you're going 100 miles an hour and she's like, "You done?" "Yeah, great."
Despite the company's insistence that the F1 is purely a road car, it is perhaps inevitable that McLaren is coaxed into making a racing version. At Le Mans in 1995, and after 24 hours of racing, McLaren F1s finished first, third, fourth, and fifth.
In my opinion, winning Le Mans once is much more difficult than winning enough races in a Grand Prix season to win a Grand Prix championship. Much more difficult. We were the first team to win it at first try, obviously apart from the first Le Mans. So that shows you how difficult it is, even with all the money that people like Audi have got. And they don't win it first time.
To this day, the McLaren F1 is often cited as Murray's masterpiece.
It set new standards in terms of lightweight, power to weight, certainly outright speed, all as part of that ethic of aiming for that preposterously low target weight.
Every now and again there is a designer who absolutely has a real single-minded vision where every detail is an opportunity to make something special, and the F1 is absolutely coated with this sort of approach. Every part of it is looked at and thought about and designed.
It's summer in the south of France, and the Gordon Murray design team is relaxing as only it can. It's the annual Soapbox Derby, all vehicles designed in-house for maximum speed and minimum weight.
It's always been part of the program, my program, that the job should be fun. And when you're doing something that you absolutely adore and love, like cars and speed and racing, that's not very difficult to achieve.
Back in the real world, the T25 is beginning to cause a stir.
It's getting an awful lot of attention. It's kind of the star of the show, really, but understandably so, because it looks visually much different to anything else on the road. And interestingly, sort of hearing kind of people's discussion, they're very aware of it. You know, they know what this car is, and they know what its significance is, and they also know, you know, the kind of the pedigree of the guy who designed it. So people seem very well informed about it. I think they're just very keen to drive it.
I think we're feeling, I suppose, like this is the end of the first part of the era. now that we have done what we set out to do, which was to build a running prototype and to industrialize the manufacturing process. But it's actually really just the beginning of the adventure, because now we're trying to sell this idea in the real world, and that's actually even more exciting, I think. Try and get as many cars like this, efficient cars like this, on the road all around the world in the shortest possible time.
Gordon Murray's design journey is a colourful and sometimes controversial quest that continues to evolve. As T25 goes through its final developments, plans for T26, 27 and 28 are already well underway. And licenses for the iStream manufacturing process are quietly being negotiated in different parts of the world.
You know, in an era where everything kind of gets homogenized in its focus groups and all cars wind up looking like Toyota Corollas, I like individual thinkers. You know, you come up with a design, people that love it or hate it. The people that hate it aren't going to buy it anyway, but the people that love it will really bond with it.
I like people who take the wheel and say, well, it's all very well, the wheel, but what about this other way of doing it? You know, to reinvent it in this other way. And there aren't many people who have the courage to do that.
Courageous means innovation, really. Looking at things in a completely different way or a lateral way. Take a chance, let's get ahead with the unfair advantage, and I'm definitely in that camp. I've been really lucky in my life because I've been paid to do my hobby, basically, all my life, and you can't get much better than that.
On the subject of the very, very fast, a brand new programme from our Flesh, Blood and Bone season explores the running prowess of African athletes. Born to Run, the secret of Kenyan athletes, is here on Tuesday at 10. Coming up next tonight, though, in a change to our Sunday night, in case you missed it last night on BBC Two, Shakespeare Unlocked. Jeremy Irons stars in The Hollow Crown, Henry IV, Part 1.